Hey guys, and welcome back. My name is MrCaproni, and this is Probability and Statistics. Today we're going to be talking about standard deviation. Now, we're going to go through the formula for actually how to find it by hand. Now, standard deviation is extremely important for probability and statistics. It's going to become as common to you as using the words average or mean in this class. So get used to it, get ready to learn it, because this is an incredibly important topic. You may be thinking, if it's so important, then what is it? Well, let me give you a short version. Standard deviation is our major measure of spread, all right? It tells us how far out the data is from the middle. So in other words, it's the average distance from the mean of each point in my data set. It is extremely important because it can completely change whatever it is we're describing. Let me give you an example. Let's say you're looking for your first job and you're either going to work for company A or B. Both companies advertise to you that the average starting salary is a certain amount, let's say $40,000. Now, if the company A has a large standard deviation and company B has a small standard deviation, what could that mean to you? Well, here's what it could mean. It could mean that in company A with a large standard deviation, it means that their starting salaries are actually extremely spread out from that initial 40,000 that they told you about. Now, if you're a really strong worker, that's great. That means you could be making way more than 40,000 starting off. But if you're a lazy bum of a worker, which let's be honest, you probably are, then they're going to pay you way less than that average. They have the chance to pay you out in a large span, not just the 40,000. Where if you're that lazy bum, luck for you, company B with the small standard deviation won't have that problem. Because they have a small standard deviation, all of their incomes are going to be much closer to that 40,000. So if you're going to go ahead and work for them, you know that even if you are a less of a worker, you're going to be getting paid about the same as everyone else there. At the flip side, you don't want to be a super awesome, amazing worker and choose company B, because you know that there's no room for you to be making more than your peers, because on average, they're all right in the same bubble. So at the end of the day, you can see the measure of spread, the standard deviation, gives us a lot more information about our data than just the mean would. That's enough with the small talk. Let's go ahead and figure out how to use the formula to actually find this thing. Now, we're going to look at two versions of the formula today. The first one's going to be the population formula, which is this one right here. You can see a lot of the population symbols that we're used to, such as the mu for the population mean, and that is a lowercase sigma that they're using for the population standard deviation. But we're actually going to calculate out using the sample standard deviation. And the reason being is this is the more realistic one to do by hand. Because if I have the data for a whole population, I probably won't have the time to go ahead and do each of the calculations by hand for it. As you can see, this is a huge formula and it takes quite a while to do. But don't worry, because when you're working with MrCaproni, it all seems as easy as pie. So we're going to go through the sample version to show you what it would look like to do it step by step. First off, some key things to note here. The X bar that you see in the top right of the formula is the notation we use for a sample mean. And the S on the left-hand side is going to stand for our actual sample standard deviation when we are all done. The N that you see reoccurring is the number in our sample. So that's how many we're actually drawing information from, if that be people or cars, objects, or things. That's how many of them that we're pulling the data from. All right, let's go ahead and get started with this. Now I'm going to go ahead and throw the formula down in the corner, and I'm going to highlight each step as we go through, as you see it in the formula. So the first thing I've highlighted there is the X bar. In other words, we need to find the mean. That is going to be step one, find the mean. So how do you find the mean? You add them all up and you divide by how many numbers there are. In this case, they add up to 415, and there are 10 of them, so we're going to divide by 10, giving us the mean of 41.5. Then from there, we're going to go ahead and find our deviations. Now, what is a deviation? A deviation is how far that number is away from the mean. Now, if it's negative, it means it's that far below the mean. If it's positive, it means it's that far above the mean. So let's go ahead and find the deviations for each of the 10 numbers in our data. So in this case, we found the mean to be 41.5. So I need to subtract 41.5 from every number in my list. Now, I can go through and do that quickly because of technology. And that gives me these deviations. Now, the big problem with these deviations is we can't simply just find the average of these numbers, because how do you find the average of the deviations? Remember, that's our definition of standard deviation, is the average distance from the mean. You would have to add them all up and divide by how many numbers there are. But the problem here is that if we add all the deviations together, because some of them are going to be below the mean and some of them above the mean, they will end up all adding to 0. And this will happen every time, since the mean is the balancing point of our data set. So we are not able to just add and divide by 10. Instead, we got to come up with a creative solution to take care of this. Think about it. Our problem is that the negatives cancel out with the positives. We want to know the total distance, so maybe we treat them like measurements. And instead of having negatives, we just get rid of them all. So what's a creative way of getting rid of negatives? Well, you can see down in the formula that our next step is going to be to square the deviations. Because if we square each and every one of them, it will make it positive, because a negative times a negative gives you a positive. So step 3 is to square the deviations. And once again, you can see quickly, I've put all of those out there for us to see. Now, if you notice, there's a symbol to the left of the highlighted area that you may not be used to seeing. That is an uppercase sigma, and they use that to represent summation notation, which essentially just means this. You take everything after it and you add it together. Now notice we had an x sub I. Now what that meant is every number in our list is represented with that x sub I. So really that's a list of numbers, not just one. So when we see the uppercase sigma there, it's telling us that we now need to add together that whole list. So now that we have them all squared, the next step is to add all the squares together. So that is step 4 to finding our standard deviation. Add the squares together. Now you can see here we end up with an 88.5 as our answer for adding the squares together. That takes us to our next step, which is to divide by n minus 1. Wait a second. N minus 1, that's not right. When I want to find the average of something, I divide by n, how many numbers I have, not n minus 1. Usually you'd be correct. But in this case, we're using something called Bessel's correction. And here's what happened. The formula has a slight error, and it's this. We are using the sample mean and a sample of our entire population to find the standard deviation, which means we're slightly off the average distance of the true mean. Because if I'm using all of my sample numbers, the sample mean is going to be the best balancing point of the data I have. Now, it is very unlikely that it's going to be the exact number of the whole population. For that reason, our numbers actually will be slightly further away from the true mean than they are our sample mean. So to fix this problem, they found out that the quick solution is to divide by n minus 1 instead of n, and that will actually give us a more accurate answer for our standard deviation. Well, now that we got that out of the way, let's go ahead and carry on with our dividing by n minus 1. Now, in this case, we did have 10 numbers, so n minus 1 is just going to be 9. So we go ahead and divide by that, and we get 9.83 repeated. And that brings us to our last step, which is going to be to take the square root of that number. And in this case, the square root of 9.83 repeated is about 3.14. 3.14. I feel like there could be some reference to that in this video, because when you're working with Mr. Caproni, it all seems as easy as pie. My God, he's brilliant. Now, guys, that is the standard deviation. That is the average distance from the mean. Don't forget what it is we did through all of this. Now, remember, usually when you find the average of something, you add them all together and divide by how many numbers there are. In this case, We had all of the deviations in a list, and we squared them all to make them positive so that we could do just that, add them together and divide by how many there are. Now, we did end up dividing by n minus 1 instead of just n because of the Bessel correction. Then we did also have to square root it because we did square everything to make them all positive. But at the end of the day, the concept stays the same. We want to find the average distance from the mean of each point in our data set, so we followed this formula to get us there. Now, I'm not going to lie, it's a lot easier to do this standard deviation thing using technology. In fact, using a calculator or a website like Desmos or GeoGebra, you can actually find standard deviation just by doing a click of a button, as you can see in the video above. But I don't like my students to start using technology until they can understand what the technology is doing. That's why I took you step by step on how to find standard deviation today. If you found this at all useful or learned something new today, go ahead and click the like button below. And if you want to keep getting videos like this, then go ahead and click subscribe because every week I'm releasing new videos. Well, thanks for joining me, guys. Remember, my name's MrCaproni, and this has been Probability and Statistics.